Hey guys, welcome to this IoT Foundation training. We're going to be talking about MQTT protocol and the importance of this protocol in IoT deployments. So my name is Johan Arens. I'm a network designer at Cisco Systems. So just a little bit of agenda. So I'm going to do an introduction to MQTT, what it is and why and when it was developed, why MQTT and why this is important. We're going to talk about the roles of the MQTT components, how does work MQTT, what is important, how to use it. And we're going to be talking about QoS, and then we're going to switch to security, and I'm going to do a short demo of the various things we talk about in this presentation. So and then we're going to conclude. So just an introduction to MQTT. So the acronym is standing for Message Queuing Telemetry Transport. It's actually made for machine-to-machine communication. So from sensors to systems that are analyzing real-time data. So this is lightweight. This is used for frequent data transfer. So very frequent data transfer has to be fast. In some situation, we are transmitting data every milliseconds or even faster. So it was based on TCP, the TCP protocol. So this is just if you're wondering. So this is it is using port 1883 on clear text and port 1888-83 for encrypted traffic. So it's standard based, this is a royalty-free protocol if you want to implement it in any project, or if you want to use an open source project. So there is no royalties to pay to someone to use the protocol. This is free to charge. So free of charge. So the protocol was created by IBM and Cyrus Link in 1999. So there were a lot of evolution since then, and actually a lot of implementation. As an example, Facebook used it for Facebook chat at the beginning of the service. So it was used for that kind of application as well. So just to let you know. So why MQTT and why this is important? So if we move back, if we move backward a little bit, so the value of IoT resides in data. So we're gonna have a lot of data coming from a lot of places, and we need to be able to have a central point of collection, and we need to structure the data. So this is why we created MQTT, and we needed something lightweight and something really fast. So keep in mind the sensor have little resources, and this is usually very cheap equipment. So typically $5 to $15, and in some situation even less. This protocol, those sensors, they have limited resources in CPU and memory. So typically, if we have a multiple system that want to consume the data, poking the same sensor is not going to scale, and the sensor might crash. And some of them are battery operated, so the less the better. So unless we are going to kill the battery in any time. So here another problem in IoT projects: bandwidth might be limited or from poor quality. Let's imagine an old rig where we are using a satellite communication, so the latency is terrible and the bandwidth is not there, and it's used as well for multiple things. So it could be a problem. So we need to take this into consideration when we are deploying some networks for IoT. So the solution needs to be evolutive, and that we don't want to be limited to one or two way to structure the data. It needs to be flexible, and I'm going to show you this how it could be flexible. We need a central point of collection, so for the data, and a central point where the data can be consumed from, and it has to be simple to operate, and it has to be secure. So just to switch gear, the roles in MQTT. So this is machine to machine. So we actually with three roles. We have a publisher, we have a subscriber, and we have the broker. The publisher is actually the sensor that is publishing the data. So then it's going to publish the data to the broker. The subscriber, this is just the system that is getting the data. So there is a subscription mechanism, and I'm going to talk a little bit about that in the next slides. And we have the broker, and see the broker as the distributor or the server. So the broker is going to collect the data from the publishers and is going to distribute the data to the subscriber. So this is the role actually. So like I said, everything transit to the broker, and keep in mind we can have a broker to broker communication. So let's imagine an enterprise with 5 plants. We could deploy a broker in each plant and one broker in the data center. We can establish a broker to broker communication with each plant and the data center. So as an example, if the plant number 1 wants to consume the data from plant number 2 to compare some values or whatever else, it could only consume the data from the broker in the data center. So the communication don't need to go back to plant number 2. So it's going to save a lot of bandwidth. So it's the operation are very simple with MQTT. So the publisher is sending the data to a topic. And what is a topic? A topic is actually a tree. So just like any file system on your workstation, for example, directories and files. In the file system, a directory is a branch, and a file is actually a leaf. So this is where the data is residing. So in an MQTT topic, so the data is the last name actually of the branch. As an example, here we have corp, we have building 11, we have floor 2, we have northwest, and we have temperature. And temperature is our leaf, and this is where the data is going to be. The topic itself is actually ASCII characters, and the leaves is actually UTF-8. So we can use various character styles. So we are not limited to Latin character. We could use Arabic, we could use Indian languages or Asian languages. Characters here, this is going to be supported. So this is actually whatever is supported by UTF-8. So just a few limitations when you're creating topics. So topics are case sensitive. This is very important. So just avoid to start a topic with a slash. In Unix, this is mandatory, or in Windows, this is mandatory. In MQTT, a topic does not have to start with a slash. If you use a slash, it's not gonna work. Avoid to use any spaces, any special characters, and keep in mind, try to be concise and accurate. Like I said, this is very flexible, the way we can lay out the topics, but the less the better. Keep in mind to try to be concise and to structure the data to make sense actually. So it's going to be much easier if the data is well structured to search for data later on. So just in operation mode, so the subscriber itself can register to a topic. This is one-to-one. So the broker is gonna send the data as soon as it's published to the subscriber. So this is the way it works. This is quite simple. In some way, if you want to receive to receive multiple data in one registration. With a subscriber, we can use a wildcard. So we have two. Actually, we have the plus signs, so it's replacing one level, and then we have the hashtag that is replacing multiple level. And I'm going to show you what the difference with an example. So here I've created two topics. We have corp branch 1 floor 1 temperature, and then we have the same for floor 2. So here as an example with the plus level, so if I want to get all the temperature for all the floors for branch 1, so I can register, I can subscribe to corp / branch 1 / plus / temperature. And I can, as an example, if I want to receive everything that was published under corp, so I can use corp / hashtag sign. So we have a few reserved topic. So one of them important. So this is door sys. So this is a telemetry from the MQTT broker. If you want to monitor what the broker is actually doing, so you can use this. And here I put a few examples of what is available. If you want to explore, feel free to register to subscribe to door sign sys / hashtag sign. And you're gonna see there was a bunch of other variables you can play with. So just to switch gear, let's talk about QoS. And actually we have three levels of QoS. We have 0, 1, 2, and 0, 1, and 2. So just to put some nuances with the QoS, there is actually no link with the network QoS. So this is layer 7 QoS. This is application level QoS. Just keep this in mind. This is really important. So as an example, if I'm using QoS1 with MQTT, we are not going to tag the packets with any DHCP value. This is only application level QoS. This is an important nuance just to avoid some complication later on. So QoS 0 is actually the default. This is just an equivalent to a radio broadcast. If we are there to receive the broadcast, yeah, good guy, you got it. If not, just too bad, you just missed it. In some situation with live data, we need to analyze a piece of information to take a decision based on the live data. This is just a perfect application. Let's say if temperature is above 15 Celsius degrees, I need to do this or I need to do that. So I don't care about the historical values, the previous value, I don't care about that. But if I do, I need to use some other mechanism because then I might have some network problem, might have some, I was disconnected from whatever reason. So we have actually a mechanism. This is QoS 1 and 2, and I'm going to talk about the nuance between the two. But first of all, how does it work? So we must use a client ID. And a client ID is a unique identifier that allows the broker to identify the client and to keep data in cache from them. So this is the way it works. So as an example, if I want to absolutely receive all the temperature logged for a specific sensor, I can register to that topic with the QoS value. So the broker is going to keep data in memory for me. So what is the difference between the QoS 1 and 2? So in QoS 1, the broker cannot guarantee any duplicates, while in QoS 2, the broker is going to guarantee there is no duplicate in the data. So why did we create those different operating values? So back in the days where the CPU and memory were quite limited, in 1999 or in 2000s, So the CPU was a challenge with a lot of data. That was a challenge as well. So we create, and the mechanism used to guarantee there is no duplicate is quite a little bit CPU intensive, at least for the days back in the days. But nowadays there was no challenge. We have very powerful CPUs. We have multiple cores, so there was no point of using QoS1 anymore. So if you need to get a copy of data, to need cache data, just use QoS2. There was no point not using it. Just another point about QoS. So the caching actually can be stored on disk or only in memory. This is optional. Actually, this you need to set this up in the configuration of the broker. And the time to live in the cache can be adjusted as well. So let's, as an example, 30 minutes, 60 minutes, 2 hours. It depends on the available memory for the broker and the amount of data you want to cache, but this can be adjusted. And the broker, they will keep the data only for a few minutes. So as an example, Mosquito, the implementation I'm going to be using for demonstration, the time to live is 30 minutes, 30 by default. So keep in mind, this is really important to use the QoS. We need to, the topics must be published with QoS1 at least. So this is important. The client ID must be known. That means to use this, the client must have registered at least once before with the broker. So the broker needs to know that specific client ID, ask to get a copy of that specific, to get some cache from a specific topic. So this is really important. If you don't do this, it's not gonna work. There was a second mechanism I want to talk about. This is clean session, and clean session is actually a way to tell the broker, yes, we have registered for caching, but no, we don't want to get a copy of whatever has been cached. So just go ahead and flush the cache. We don't want it. So by default, this is actually activated by default. So if we don't want this, we need to tell the client to disable the clean session. And I'm going to show you this in the demo. Just to switch gear, security. Both authentication and encryption are optional, and the reason being the sensors, they have a limited CPU and memory, so encryption can be a challenge. And the first challenge is the fact we need to generate some SSL certificates to be able to use this. In some implementation where the sensors are quite old or the CPU and memory are very limited on this unit, it could be a challenge. And keep in mind, it could be a challenge to deploy this. Let's say we have several thousand sensors in the network, so it could be a challenge to distribute our encryption certificates to those or to each of them. And same for authentication. It depends actually, but it could be mandatory or optional. By default, with at least with Mosquito, this is actually optional, but it could be mandatory. It's up to you, but you have to adjust it in the configuration. So just to switch gear, we're going to do a quick demo. So we're going to be using a 4-piece demo. So we're going to have one broker, we're going to have a publisher, and 2 subscribers, and those are virtual machine actually. So I'm going to jump to the virtual machine. So we have one pub over here. We have the 2 subs, and everything actually is using DHCP. I don't care. The only fixed IP I need is the broker. So the pub actually is 210. The sub 1 is 209, and sub 2 is 207. On the publisher, I'm going to be using some script because I want to publish or various values at once. We're gonna start with publish. This is a simple one. So with this one, I want to publish three messages, three different messages to the same topic. So the topic we're going to be using is Corp branch 1 for 1 temperature, and then we are going to publish this message. So the syntax we're going to be using with the pub, and you can see here mosquito pub. So this is to publish data. So -h, this is the host, this is the broker, -t is the topic, -m is the message I want to publish. And here on the sub 1, this is mosquito sub as opposed to mosquito pub. -h for the broker, -t for the topic I want to subscribe to, and this is the name, and -v, this is the verbose that allows me to print the topic name when I'm going to receive some data. So I'm going to go ahead and start this, and same for our friend the sub 2. So here nothing is happening, and the reason being I'm not publishing anything. So I'm going to go ahead and to publish something. And here, so you can see I'm publishing those three messages, and here I got a copy of the three messages. So we have a sub 1 and sub 2, and then we receive the same data. If for some reason sub 2 is disconnected from the network and I'm publishing again, sub 1 is receiving all the three messages, and nothing happened, of course, on sub 2. And if I'm starting this guy again, nothing is happening. So it missed actually the data. So I'm going to publish again some data over here, and here this guy received the three messages, and same from sub 1. So now I want to make sure that sub 2 is receiving the data. So this is the data is really important for us. So I want to make sure this guy received the data. So I'm going to go ahead and register this to QoS. So I have set up a client ID. This is -i and some name. You can use whatever you want, but it has to be unique. So you cannot have a sub 2 on one side as a client ID and sub 1 and sub 2 on the other side. It's not going to work, and it's going to be the connection is going to be rejected by the broker if you do that. So let's register to the broker with this. So at least once I'm going to disconnect, and I'm going to publish actually QoS, and I'm going to show you what is inside my script. So this is the same thing. The difference is I'm going to publish it as a QoS2. Like I said, I need to publish in QoS mode as well. So I'm going to go ahead and register and start this. So sub 1 received the data, sub 2 did not, because I was not connected. So I'm connecting and nothing is happening. And why is that? It's because clean session is disabled, is activated by default. And like I said, we need to disable this guy. So I'm going to start this again. I'm going to tell the broker, by the way, don't use clean session with me. I'm going to disconnect again. I'm publishing, and I'm going to reconnect again. See, I can receive my data. Okay, so this is the way it works. So you can see here I can be disconnected, and I'm sure I'm gonna get my data, and I'm going to publish a few times in a row. Here we go, and I'm going to start again, and here I've got the copy of the data. So this is how it works. So now we have another problem. So we are publishing some data, and I'm going to show you the script I'm going to be using. So we are publishing some data for some temperature data for a few floors, and then I'm gonna get asked by the development team to receive all the data at once. So the challenge we have here, if I do this, and I'm going to execute the script just to show you what's going on. So here you see I'm publishing the data multiple times in a row, and actually I'm only receiving one flow actually, and this is the reason being is because I only subscribe to this piece of information. So if I want to go ahead and receive all the 3 flows at once, I need to use the wildcards. Like I said in the presentation, I can reuse the plus sign, and I'm going to register to do this. Okay, so now I'm going to publish again, and I'm receiving data for all the 3. This is one way to do it. Another way will be to use the hashtag sign. So I can use the hashtag sign instead of this, but here I can use this, and let's do this and see I'm receiving all the copies. The problem with this is the fact if there is some other information, other variables that is published under flow 3, I'm going to get it, and in some point I'm going to mix several types of information if I'm using this. But it depends, actually. It depends how the data is structured, how you want to use it, but it could be useful, it could be a problem, but it depends, so be careful with using this. So that is concluding the demo, that is concluding the presentation. So we have seen why MQTT is important in an IoT project and how it could scale, help you to scale, help you to structure the data. So we're gonna have with MQTT, we're gonna have one central point of collection, data collection and publication. So it could be very useful for your IoT projects. So MQTT is used in many IoT software. So this is really useful. So to publish and to register, to subscribe for some data. So it could be very, very useful for your implementations. So we have several mechanisms to for bandwidth problems. So with the QoS, we have seen we have 2 levels of QoS actually to help us protecting against the network disconnections, and that we can make sure we're gonna get the copy of the data if this is important. So I hope you have found this this training useful. So please go ahead and like it in YouTube. It's valuable feedback from me. And if you have any comments, something is missing, and something another subject you want to see covered in the next training session, please go ahead and add some comments to the video. If you want to have the slides of the video, don't hesitate to comment, to ask for it in the comment section. I'm gonna publish the slide as well. So thank you for watching and have a good day.